For the 50-second problem on the second ACT practice test, which of the following is true for all consecutive integers m and n such that m is less than n? So to solve this problem, we first need to understand what an integer is. So integers are essentially whole numbers, and integers also include 0 and the negative numbers. So we can say 0, 1, 2, 3, and so on. These are all integers, but also -1, -2, -3, and so on in that direction. These are all integers as well. So you can think of an integer as simply just a whole number. And we're also told that we're dealing with consecutive integers. So consecutive just means one after the other. So for instance, 1 and 2 are consecutive integers, but also 2 and 3 are consecutive integers. So if you were to pick any number at random, 8, you can find consecutive integers on either side of it. So we're said we have these two consecutive integers such that one of them is bigger than the other. In particular, n is bigger than m. So let's go through each of these choices and see if we can figure out if it's true or not. And my advice for this problem is to just pick two particular integers and see what happens to them. So if we were to pick 8 and 9 as our two consecutive integers, then for this first problem, m is odd. M is the smaller one. So in this case, the smaller one is not odd. But if I were to have said 9, 10, in this case, the smaller one is odd. But since we can't decide which set we should choose, there's no rule saying we should choose this one rather than this one, then you can't conclude that m is always going to be an odd number, because sometimes it's going to be an even number. So that one's not true. But the same argument could be made for the fact that n is odd. You can see in this one, since n is the bigger number, that it is odd, but when I chose 9 and 10 as my consecutive integers, n was even. So this one is not always true as well. So let's just eliminate both of these choices. Now we have to look at h. n minus m is an even number. So in general, when you're subtracting two consecutive integers, one from the other, you're always going to end up with 1. Since 10 minus 9 is 1, or if I chose 3 and 2, 3 minus 2 would be 1 as well. And 1 is an odd number. So h, this can't ever be true. Now n squared minus m squared is odd. So if we chose, let's say, just this 9 and 10, we're squaring each of these numbers and subtracting the smaller number from the bigger number. 10 squared is 100, minus 9 squared, which is 81, and this gives us 19. So that actually worked. Now let's try another pair. We have 9 and 8, so 9 squared minus 8 squared. 9 squared we know is 81. 8 squared is 64. 81 minus 64 is 17. So we got an odd number again, so maybe this one's correct. Let's see if we can eliminate the last one, and then we'll know for sure that j is right. So now we have to consider m squared plus n squared. So we'll just use the same pair of numbers. But in this case, we're going to add them. So 10 squared plus 9 squared. So 100 plus 81. And 100 plus 81 is simply 181. And 181 is an odd number. So just by the first example we chose for this m squared plus n squared is even, we've already found a case where it's not true. So this can't always be true, and that just leaves us this possibility, which we know for the first two times that we checked it that it did work in either case. And we already know for sure the rest of them are wrong. So this one is true in all situations.